These notes here are going to discuss properties of trapezoids and kites. The last two are quadrilaterals. And so these are some words that we need to know. So if I make a reference to them, you'll know exactly what I'm talking about. First of all, a trapezoid is a quadrilateral with exactly one pair of parallel sides. That's important. That's how we define a trapezoid. The parallel sides of the trapezoid are also called bases. So we don't say parallel sides, we call them the bases. Usually it's the top and the bottom, but not always. The base angles of a trapezoid are the two pairs of base angles. Each pair shares a base as a side. The legs of a trapezoid are the non-parallel sides of the trapezoid. So the sides that are not parallel are called the legs. And of course, in the isosceles trapezoid, you can kind of put two and two together. An isosceles trapezoid is a trapezoid in which the legs are congruent. And the midsegment, again, that's a word that you should know. The midsegment of a trapezoid is the segment that connects the midpoints of the legs. And of course, this is kind of separate, but we'll talk about a kite is a quadrilateral that has two pairs of consecutive congruent sides. That means the sides next to one another are congruent, but the opposite sides are not congruent. So we'll talk about all these as we move through the notes here in a second. First of all, we have this theorem here. And so just like all the others, we got to know the properties that relate to a trapezoid. If a trapezoid is isosceles, then each pair of base angles is congruent. So this is only if you know or are told that you have an isosceles trapezoid. All right, so we know that isosceles is where the legs of the trapezoid are congruent. That means the base angles, that's the angles that are next to or connected to the base of the triangle, are congruent. So you got a base up here, angle B is congruent to angle C, and a base down here, D, is congruent to angle A over here. Here's another theorem. If a trapezoid has a pair of congruent base angles, then an isosceles trapezoid, it is an isosceles trapezoid. So what does that mean? This is just the reverse of this one. You can prove you have an isosceles trapezoid if you got a pair of base angles. That's all that's saying. So it's pretty much the same theorem there. Now, a trapezoid is isosceles if and only if its diagonals are congruent. That means the diagonals in an isosceles trapezoid are congruent. All right, that's very important to know as well. This stuff, you know, will come up as a question. So what we're doing now is just reviewing the different theorems that relate to trapezoids. And so far, it's just dealing with isosceles trapezoids. Now, let's talk about the midsegment theorem. The midsegment of a trapezoid is parallel to each base, and its length is 1/2 of the sum of the lengths of the bases. All right, in plain English. Remember, a midsegment is the segment that connects the midpoint. So M is the midpoint of AC, N is the midpoint of BD, and so the midsegment is that segment that connects those two midpoints. You can see by the marks there that that's the midsegment. Notice that it's parallel to the bases. You see that? That means that AB, MN, and CD all are parallel. That's important. Remember, alternate interior angles and alternate exterior angles and corresponding angles, all that stuff from parallel lines may come into play here. If MN is the midsegment of a trapezoid, and they give you this formula here, MN equals AB plus CD divided by 2 or multiplied by 1/2. So you can tell the relationship between the length of the midsegment and the length of the bases by adding the bases together, dividing them by 2, and that should equal the midsegment. All right? Now, let's talk about a kite. If a quadrilateral is a kite, then its diagonals are perpendicular. So one of the things we know about a kite is the diagonals are perpendicular. Now, one of our original statements was that consecutive segments are congruent. So that means BA and BC are consecutive. They are congruent. CD and CA are consecutive. They're congruent. But opposite segments are not congruent. Opposite means they don't share a vertex. So CD and BA don't share a vertex. They're not congruent. AD and BC don't share a vertex, so they're not congruent. All right. But anyway, this particular theorem is talking about that the diagonals make a perpendicular intersection here. This next theorem says if a quadrilateral is a kite, then exactly one pair of its opposite angles are congruent. So the shorter side, I always call them the shorter side angles, not the longer end, but the shorter, like diagonal, those angles are congruent. All right. So those are kites, quadrilaterals. I think that's it. So let's actually talk about how we use these and where it comes up. Okay, so here we have a couple of problems, and we're going to see what it's like to deal with a trapezoid and a kite. Now, notice here, nothing tells me that I have an isosceles trapezoid. So a lot of that stuff I just got through talking about doesn't exist here, but I still need to be able to find angle 1 and angle 2 here. So let's look at what we know. This is a quadrilateral, all right? So consecutive angles should add up to be 180. Even if you don't remember that or know that, you should remember that from parallel lines. If I have two parallel lines here, and here's a transversal, remember if they're on the same side, they're supplementary. So that means this angle plus this angle should equal 180. So again, just in case you don't understand what I am saying, let me show you by doing this. If you look at number 1, I got a parallel line, but if I kind of do this, and I call this angle 1, 2, 3, 4, 5, 6, 7, 8. Angle 4 and angle 6 are not equivalent or congruent. They're supplementary. And that's what we have here with 87 and angle 1 there. So all we would do is say 180 minus 87, and we know that angle 1 has to be 93. We can do 68 and 180, and we find out that this angle has to be 112, because it's the same idea here, that if I did that and put 68 degrees here and wanted to know what this angle was, or maybe I call it X, then those are also supplementary. So we have to use parallel lines, those rules, to help us answer questions like these here, because I don't know that it is isosceles. All right, so let's look at number 2. Again, I just have a parallel line, and the consecutive angles have to be supplementary. So if this one is 90, angle 1 has to be 90 as well. And notice I'm not setting up an equation. Why? Because they're just giving me numbers here, so I can figure it out. I can just think through it or use my calculator. And 137 minus 80, excuse me, not 80, but 137 minus 180, or actually the other way around, you'll get 43 degrees. So this one should be 43 because those two are supplementary, and this one, number 1, should be 90 because those two are supplementary. And again, I'm using parallel lines, not necessarily trapezoid information to figure that out. Now, if you look at number 3 and 4, they tell me I have an isosceles trapezoid. Okay, so it's very important to know what an isosceles trapezoid is. When it comes to finding these angles out, we know that an isosceles trapezoid, the legs over here are congruent, and so that means that the base angles, this is a base and this is a base, the base angles are the same. So if this angle down here is 77, then angle 1 also has to be, that's right, 77. So if both of those angles are 77, that means that these two angles have to be 206 added together. What are you talking about, Mr. Freeman? Now, don't forget that since this is a quadrilateral, all angles of a quadrilateral add up to be 360 degrees. So if this one is 77 and this one is 77, and you multiply or add those two together, you get 154. If you do 360 minus 154, you will get 206 for both of those. But remember, these two are base angles as well. What does that mean? That they're also congruent. So if we actually divide those by 2, we'll get 103. So this one is 77, this was 103, and this is 103. Now I didn't write anything down, but I will in a second. All right, using this problem as an example, let me just write it down so that you can see what I'm doing. All right, so if this one is 77, this one is 77 degrees. All right, and what I did was I did 360 minus 154, and I got 206. Now where did 154 come from? Those two added together. Where did 360 come from? All four angles add up to be 360. Since this is an isosceles trapezoid, that means not only are these two base angles the same, but these two as well. So if both of these add up to be 206, all I have to do is divide it by 2, and I'll find out that both of those are 103 degrees. That's what I did on that particular problem. Now they kind of rotated this one a little bit, but it's still the same. If this angle is 62 degrees, then angle number 2 has to be 62 degrees. 62 and 62 is what, 124? And so if I do 180 minus 124, oops, not 180, 360 minus 124. So that was a mistake. I said minus 180, but I meant 360 minus that as well. So not 180. You gotta be careful. So when I do that, you get 236, and 236 divided by 2 is 116. So this has to be 116. This is 62, and this one is 118. Now again, where is this coming from? The base angles in an isosceles triangle are congruent. All right, let's talk about a kite. All right, I know I have a kite here, and so angle 1 is 90 degrees. I already know angle 1 is 90 degrees. It's that important to know that angle 1 is a 90-degree angle. All right, so let's come over here and talk about the rest of this. Now, if angle 1 is 90, they want to know angle 2. Now, what's important about this? Well, we know that this is a 90-degree angle right here. In fact, if I wanted to, and this is a good idea, sometimes it helps for you to do this. Just separate it out. All right, and this is angle 2. All right, so now, since I separated it out, you can kind of see clearly. I'm not saying that this is 2. I'm saying that that's just angle named 2. All right, so how does this work? All three angles of a triangle add up to be 180, right? So 180 equals, well, let's not do that. 90 plus 65 equals 155. All right, if I take 180 minus 155, I'll get something. 25 degrees. All right, so I'm using a kite to figure that out. And how did I do that? Well, that's 90, that's 65, so this one has to, all three of them have to add up to be 180. How did I know this was 90? Because bisectors are perpendicular. All right, not really sure where that angle is pointing to, but it's the same idea. If this angle is 51 degrees, this one is 90, you add those two together and subtract that answer from 180. Now, I don't have a lot of time, so this is where I would say this plus this equals 180. They're consecutive angles, and they add up to be 180. If this is isosceles trapezoid, we know that those two sides are congruent, so we set those equal to each other. All right, running out of time.